hurdles of app migration, and we are going to take this presentation through discussing about various challenges that a business faces when they try to migrate the databases. And then we will continue the same example of Bob Bookstore, which is like an application into .NET Core and Microsoft SQL, and how migration from that to Postgres will happen in time. So let's start with some industry facts. Like about 60% of database migration projects fail, and in theory, like 62% of them, they fail due to the application and database updates. 76% of them, they have complex integrations and app dependencies, and about 57% has lack of comprehensive documentation and version control. So if you look at it, like many companies have a complicated application and database scenarios, which essentially means that one application connects with multiple databases and multiple apps talk to a single database. Like for example, in case of like e-commerce, maybe there is a separate database for user profile, product inventory, order history. So all of these databases are used by a single e-commerce application. Then in the other situation, sometimes like multiple applications are connected to a single database. Like if product inventory is the database, then e-commerce application, supplier application, loyalty rewards application, different applications can stay connected to the single database. That becomes a problem. About 24% of the companies say that they have established application and database version control systems. Some companies have application version control systems, may not have database version control system, and vice versa. So biggest impediments to all the application and database migration project is undocumented applications. And most of the legacy databases the legacy applications or databases that we had were built 15 years ago, like during probably in ASP.NET, Microsoft SQL, or Java, Spring, and Oracle, and so on and so forth. Which means that most of those databases were relational databases, though the use cases were different, but still that was the only database available at that point in time. That's why it was the case. Many companies also face a code migration challenge because like over the period of time, though those applications were built in those legacy systems, and companies decided to upgrade databases from like 2005 to 2008 to 2012 and so on. But still applications remained monolithic, and that became another problem as well. So in the further slides, we will talk about the details on each of the challenge in migration and potentially how that can be solved, and basically what kind of automation can be used to solve that quickly and essentially de-risk the approach of migration. And we will see some of the components working in action in the form of demo. So first and foremost, like the applications with like about 15 years of legacy. So what happens? Like these applications, they likely to go through version upgrades over the period of time, but they follow similar monolithic project structure over I would say, modular or flexible project structure. Most likely you will find that business logic is written in stored procedures. They have tremendous dependency on outdated elements such as like link queue or data source controls, or very old type of connecting applications with databases. And therefore, they will have compatibility with modern systems. Because modern databases or modern applications should be designed considering high availability, global distribution, and active disaster recovery scenarios, legacy databases may not support these type of additional features. And these things, they result into additional downtime with more support, and that incurs 40% more technical debt. Most of these databases are built using relational databases like SQL or Oracle. And these faces like number of challenges. Like one of the fundamental challenge in that is about the schema rigidity. Like in the relational databases, schemas have to be fixed. Schemas have to be fixed. They have so many constraints. And then due to that, if you want to scale such databases, they will run into scalability issues. And then the more constraints, the more performance trade-off. And these databases do not provide like flexibility to work on a lot of NoSQL use cases. There are many challenges with that, can be discussed into greater details, but these are high-level challenges of using relational databases to every single use cases. One of the other most common challenge that we find is undocumented applications and databases. Like there is always a knowledge gap between what the architecture is, what kind of different data structures do we have in the application. Sometimes like there can be issues related to data integrity and business logic if these things are not known ahead of time. Most of the times, companies rely on like the key people who have been with the business for the longer period of time to help them navigate through the process. But the reality is that multiple engineers work on the application. There are third-party vendors, contractors, consultants. Everybody contributes into this application, and it becomes practically impossible for key people to know what's going on in the system, even if they are with the business for the longer period of time. And we try to solve some of these challenges by deploying automated discovery and assessment tools, which essentially make sure that the analysis of application and database migration is happening based on the actual data and not based on the hearsay. These days, like obviously a lot of tier one vendors like AWS, they have automated tools for database migration. Like you might have seen SCT or DMS, which actually helps you convert schema from like Microsoft to Postgres or Oracle to MySQL and so on and so forth. We need to also change applications to make sure that this happens. Like because different database systems have different variations of SQL syntax, functions, and features. The application code that contains SQL queries, probably stored procedures, and database interactions, they may need to be modified to align with the new syntax. There will be issues with the data type compatibility, and therefore there might be issues in printing those data types into applications. So all that needs to change. There are definitely different constraints and different kinds of key structure in based on different database to database. And these types, if not handled properly in the application code, can become problem. There can be third-party libraries and frameworks which can also integrate with applications. So all of these application codes need to be changed in order to make sure that the application and database are compatible after migration. Whilst SCT is a great tool to do the database migration, there's a requirement of automated tools to actually discover all of these changes to be made in the application and eventually make that change. So we have some of the tools which can help accelerate that effort and make sure that all these migrations are done in a risk-free scenario. Of course, there are downstream data pipeline compatibility issues as well. Like most of this transactional data databases are connected to data pipeline in one or the other way. Either it can be with modern data lake or lakehouse kind of pipeline, or it could be traditional ETL pipeline with the use of tools like Matillion or Informatica into data warehouses. Of course, when those data pipeline jobs have to be modified for their data format and compatibility, otherwise we will face a lot of data consistency and integrity issues. If these ETL jobs are not modified correctly, they can result into performance bottlenecks, and eventually all of those things have to be de-risked to make sure that the migration becomes successful. So in order to do that, we try to distribute all of this into different stages. So during the assess stage, we do the application load analysis, application dependency analysis, schema conversion analysis, and data pipeline analysis, the ETL analysis. During the design stage, we have to define the DevOps architecture, which helps us understand which these applications connect. This database connects to how many different applications, what kind of connectivity is required. Is it private, public connectivity, or federated connectivity required to control the right access? Then what is the change management philosophy for app and database? If there are no change management tools for application or DB, We have to deploy the change management, design and deploy change management system as a part of that. And we have to also design the ETL migration architecture depending upon what the source ETL system is and if ETL systems have to be migrated. During the build stage, we convert schema, migrate data, migrate objects, migrate data pipelines. Obviously, it includes the migration of automated migration of application code, database schema and objects, integrations, data integrations and APIs, and eventually data migration, which is one-time snapshot and the change data capture. Once all of this happens, a lot of organizations need help with the right kind of testing for schema, for data accuracy, for code, for application integration, load testing, and most likely the unit and integration testing. If companies do not have automation built in, automation testing built into the application, then we build that automation testing system in the source application as well as destination application, so that like the business is assured that their source and destination works perfectly fine. And obviously there has to be a cutover plan and there has to be a rollback strategy to make sure that all of these things work as expected during the cutover stage. So let's look at the cutover strategy in some of the detail. So usually, like during the cutover, first step is that we do the final schema migration, then full load and change data capture. So the data is loaded into Postgres. Automation testing validates the system. Meanwhile, that happens, business runs as usual on the correct system. Then we do data validate. So when the app gets pointed to the new database, the data validation on future system happens. After that, new application and database is available. During that time, we use CDC to migrate data that was lost during this period of time. The data gets loaded into Postgres. Meanwhile, as the validation is in progress, we stop the current application. Then data validation happens for future system. Then we connect with all the third-party applications and data pipeline. Then the present application remains in the stop stage. The new application becomes in production and business validation continues on future system. And when this is done, the application goes live on the newer database. Now, considering here that we are migrating from Microsoft SQL to Postgres. So all of this process typically happens somewhere between 0 to 15 minutes in most of the cases, but in very complex application and integration scenarios, sometimes this process can take about 1 to 2 hours. And idea here is to make sure that before we go live with application and databases and data pipelines, all things are thoroughly tested automatically so that the migration can be concluded confidently and in a risk-free environment.